Welcome everyone. Today's lesson is on three forms of the quadratic relation. So we've already studied these three forms. We have our factored form, our standard form, and our vertex form. And we want to just first look at what is the advantages and disadvantages from each form. So what information can we directly extract from each different form of our quadratic? So let's start with standard form. One advantage we would know from standard form is the direction of opening, because we know if we just look here right after the equal sign for any of these, we would know an advantage is if we know it opens up or down. So direction of opening. And this one would open up because we have a positive sign here. The other advantage of standard form is right here, the C value is our y-intercept. So we can identify the y-intercept. The disadvantages of the standard form is we cannot identify the vertex, which is an important point, important point on the graph, or the zeros or the x-intercepts. And sometimes we need these points in order to answer questions as well. So once again, standard form is good for our direction of opening and our y-intercept. Factored form. So factored form, once again, you would be able to identify that this opens up from the form, so direction of opening. And the other thing we're able to tell from factored form would be the zeros. We know the zeros for this particular equation are -3, 0, and 1, 0. So we know the zeros from factored form. Looking at the disadvantages is we cannot identify the y-intercept or the vertex. So we're unable to read those directly from the equation. Now looking at vertex form, once again, we can tell the direction of opening, so that is an advantage. As well as we know the vertex. Remember the vertex here would be a -4, -4. The disadvantage is we don't know the zeros or the y-intercepts. So that's why it's important that we're able to move from one form to the other. Depending on what the question is asking us, we might have to take one form and rewrite it in one of the other two forms. So let's look at some exercises here first. State the features that can easily be determined from the following forms. So state the y-intercept of the following. Remember, the y-intercept is the C value, so our y-intercept here is 0 and 48. Once again, it's in standard form. We can tell the y-intercept, so it's 0 and -15, and the y-intercept here would be 0 and 2/3 over 25. Remember, as you're watching these videos as well, you could actually come and complete this if you feel comfortable already in these questions, and then you could just come back to the video at the end to check your answers. So that's another way to use the videos rather than just watching them as I go through. If you feel comfortable, you should do the work first, and then you could, if you get any of these wrong, the answers are at the bottom here. If you have any of these wrong, then you could come back and see how I have solved them here on the video. And remember also, if you don't have the way to print these out, you can just write these equations on your own on a piece of paper, just like old school, like I used to have to do. Didn't have computers and printers then. We used to just write down our questions from the textbook or whatever, and then supply the answer underneath. Number 2, state the zeros of the following equation. So remember the zeros, when I take it out, I change the sign. So my 0 here are -8 and 6. Once again, the zeros here would be -24 and 0, and 18 and 0. So this last one, remember we're setting the brackets equal to 0 in order to solve. So we haven't done this for a while, so let's just do that. So it's 2x subtract 5 is equal to 0, and I have x add 6 equal to 0. Remember, we're just solving these for x, so we bring the 5 over as a positive, then we'd have to divide by 2, and the same here, we just bring this to the other side. So I know my zeros here are 5 over 2 and 0, and -6, 0. The same thing applies here. So I would set each of my brackets equal to 0. And then I'm solving for x. So I have x is equal to 3. I also have x is equal to, remember, we'll take the 1 over. It'll be a negative. And then we're going to divide by the 5 for a -1/5. So my zeros, sorry, for this one are 3 and 0 and -1/5, 0. State the vertex of the following. Remember, when it's in vertex form, we're just stating our h and k value. So for each of these, we're just writing in the h and the k value. Now, on the opposite side of the page, we're going to look at features that we can't easily determine from the equation given. So let's flip over and try some of those examples on the other side here. So in order to graph quadratic functions, we need to know that. Remember, this is the most important point on our graph, is the vertex. Depending on the form of the quadratic function, we can find the vertex using different techniques. For example, if the function is in vertex form, so remember this is vertex form. So if it's in this form, we can just directly write the vertex. If the function is in standard form, remember you're going to have to complete the square, that method that we learned earlier, to go from our standard form to our vertex form. If the function is in factored form, so this takes a little bit more work. So if it's in factored form, there is a few different ways that you can do it. But if it's in factored form, you could first find the zeros, right? And then calculate the equation of the axis of symmetry, right? And this gives us our h value. Then you can sub the h value into the original equation to solve for the k value. And then we know we can just state the h and the k value. So let's do some exercises finding our vertex from either our factored form or our standard form. And we're just going to follow these methods in order to do that. So our first one, we have change each equation to standard form and state the values of A, B, and C. So the first ones we're just rewriting into standard form. Remember, standard form has no brackets. So we know we want to expand and simplify here. So we'll do our FOIL here. So 6x squared, subtract 3x, add 4x, subtract 2, collect our like terms, 6x squared, add x, subtract 2. So A is equal to 6, B is equal to 1, C is equal to -2. Excuse me. the next example. Remember, it doesn't matter which order you multiply. You can do the brackets first and then multiply by the -2, or you can distribute the -2 and then multiply. I'm going to distribute the -2 just from the student work. I notice that is the method a lot of you use. And then we'll use our distributive property to expand this further. Add 2x, subtract 24x, add 8, collect our like terms, -6x squared, subtract 22x, add 8. I'll just do this on the side. A is equal to -6, B is equal to -22, and C is equal to 8. So that is going from factored form to our standard form. The next two examples are from vertex form to standard form. So remember, we can't multiply this into the bracket in this situation because it's squared. So following BEDMAS, we would have to apply an exponent before we can multiply. So this is a perfect square trinomial, so you can multiply them out if you choose. I am just going to use our shortcut method that we have learned in order to expand that. But once again, you could just rewrite this and do your FOIL. Then I'm going to multiply into the bracket. And then remember, these are like terms, so I will collect the like terms. A is equal to 2, B is equal to -12, C is equal to 23. Our next example, once again, you can just, because it's a perfect square trinomial, if you know the shortcut, you can just directly write it, or you can write the two brackets and you can do your FOIL and then collect your like terms. Our A here is 1, B is equal to -4, C is equal to 4. The next set of exercises will be going from vertex. We'll be finding the vertex for each function. So our first is factored form, and we want to find the vertex. So if we're in factored form already and we want to find the vertex, we wrote the steps up here. We're going to find the zeros. We're going to calculate the equation of the axis of symmetry, which is really our h value. We'll take the h value, substitute it into the original equation to solve for k. So those are the steps we're going to follow through in order to do that. So first off, my zeros are -3 and -1. So I'm going to find my h value. So remember to find that. We're going to add the two zeros together because of symmetry. We're finding halfway in between, and I find that x is -2. Now I want to find my k value. We're going to take our original equation and we're going to substitute in x equals -2 to calculate the k value. So we find here that the k value is -1. So my vertex is -2, -1. Once again, you might want to stop the video and try this one first before I do it. It's your choice. So here's my next zero. Remember, we would set these equal to 0 and then solve to get my zeros. So x, I'll bring the 3 over, so it'll be a +3, then I'm dividing by 2. I'll bring the 1 over, which makes it a -1, then I'll divide by 2. So my zeros are 3 over 2 and -1 over 2. So we're going to find the h by finding halfway between the zeros. Have a common denominator. So when we add, we'll get 2 over 2 divided by 2. But 2 over 2 is just 1, so it's 1/2. So I find that the x value is 1/2. Now I'm going to find the k. And we're substituting 1/2 into the original equation. Half of 2 would just be 1. Once again, half of 2 is 1. So we have -2 and a +2, which is equal -4. So my vertex is 1/2 and -4. So that's finding the vertex if it's in factored form. Now, if it's in standard form, we learned standard form up here that we need to do the method that we learned earlier of completing the square. So we're going to apply that method to these questions. So you might want to look back at your notes. If not, remember we take the first 2 terms and we factor out A. So I'm factoring out A of the first 2 terms. We leave a space in the bracket and we leave the C value to the side. Then we take our B value, divide it by 2 and square it, which is 1. And we take this value, we add it and subtract it into the bracket. To complete the square, remember it's just these first 3 terms complete our square. So we take the last term and we multiply it to the A value here at the front. So this would now be a +2. And then we need to write this as a squared. So it's the square root, the sign of the second term, square root of the last term, add 5. Then to state the vertex, it would be -1 and 5. Once again, we'll take our first 2 terms. We're dividing out A. It's just a -1 this time. Leave space in your bracket. Sorry, this is a -3. We'll take our B value, divide it by 2, and square it. This is what we add and subtract into our factored bracket. We have our perfect square trinomial, so we're going to take this last term and multiply it by the front and take it out of the bracket. Sorry, x squared add 2x add 1. And then we're multiplying that outside the bracket. A negative and a negative be a +1. Subtract 3. We'll write our squared, square root of the first, sine of the middle, square root of the last term, and combine our terms for -2. Stating the vertex is -1, -2. So that are the different forms. Let's turn our page to our last few examples. If we are in vertex form, we can state the vertex directly. Remember, the vertex here would be 4 and 1, and the vertex here is -8 and 0, because we're adding 0. The k is just 0 here. So here are the solutions to those. Like I said before, you're always welcome to try them first and then come and watch the video if you don't get the answers correct. Finding zeros of the quadratic function. There will be applications where it is important to find the zeros of the quadratic function. We can only find the zeros from factored form. So find the zeros of the quadratic function. Once again, remember to find the zeros, we set each factor or each bracket to 0 and we solve. So x, we're going to bring the 1 over, so -1, and we're going to divide by 2. And we'll bring the -5 over, so it'll be 5. So my zeros here are -1/2 and 0. We can write zeros here, I guess. And the other one is 5 and 0. So let's look at the next one. Set each of the factors to 0. Bringing the 4 over, it will be positive, dividing by 3. For this one, we'll bring the 7 over to a -7, and we'll divide by 2. So our zeros here are 4 and 3, 4/3, sorry, and -7/2 and 0. If we do not have it in factored form, then we have to know how to rewrite it to be in factored form. So if it's in standard form, we would want to factor this. So remember to factor, we set up our two brackets. I need all the factors of the A and the C value. So the C value, we don't have choice. We're just going to substitute in a 1. And remember, the strategy we use is we first try the ones that are closest together. Doesn't always work, but that's where we're going to start. And then remember, do your smiley to see if this works to your middle term. Sorry. I have 3 and 2, and I need a positive 1. So that means I would have to make the 2 negative and the 3 positive. So if the 3 is positive, the positive sign goes here and the negative sign here. So my zeros would be -1/2 and 1/3. Sorry, don't forget you're going to set those equal to 0, just like we did in the ones above. I guess I should do this here for you. I shouldn't have skipped that step. Remember, the 1 comes over for a negative and then divide by 2. And over here for this one, we're going to bring the 1 over for a positive 1 and divide by 3. The next one, once again, it's in standard form, so we need to factor this. We only have factors of 1, so we have no choice. It'll just be x and x in our first bracket. And then in the second bracket, we have 1 and 14 and 7 and 2. Just looking at this middle term, though, I know I'm not going to pick 7 and 2 because I can see 13 would be better suited for the 14 and the 1. And since the 13 is positive, I know this 14, the larger integer would be positive and the smaller one would be negative. And the zeros for this one are -14 and 0 and 1 and 0. So that is the lesson today on just converting from one form of the equation to the other, because when we get into our problem solving parts of the unit, we need to be able to extract different information about the parabola, and different forms gives us different characteristics of the parabola. So that is our summary of how to find different forms of the quadratic function.